Hello guys, how are you again? In this video, we're gonna talk about hydrogen forces, which is the second type of intermolecular forces. We said that we have dipole, dipole forces, and now we're gonna talk about hydrogen forces. Now, hydrogen forces, before we start our lesson about it, we have to know that it is a very important type of forces for the living organisms. For example, the main reason that stabilize the DNA in our bodies is existence of hydrogen forces between DNA molecules. This is why the DNA is stable inside our bodies. And what is the meaning of hydrogen forces? It is a type of forces that formed when a compound contains hydrogen and one of those atoms, oxygen, fluorine, and nitrogen, atoms with a high electronegativity. So when we have a compound that contains hydrogen bonded to high electronegative atom like oxygen, fluorine, or nitrogen, then we will find the hydrogen bonds. And for example, if we talk about water, this is water, as you know. We have a lot of molecules inside the water compound with a different arrangement, of course. Now here, in such compound, the hydrogen atom here will attract an adjacent oxygen atom. So the attraction here happens between an atom of the first molecule, which is hydrogen in this case, with an oxygen atom of another molecule, and so on, as we can see here. And so on. Now, it is good to know that if we talk about only one hydrogen force, for example, only about one, alone it is considered a very weak force, because finally this is not a chemical bond like covalent or ionic bond. No, it is just a type of attraction between two atoms in a different molecules. But when we talk about this huge number of attraction between molecules, that means that the connection strength will increases. And this is the main reason that make such compounds have a high boiling point. For example, remember when we talked about the ionic compounds and molecular compounds, we said that usually the molecular compounds are gases at the room temperature. And the boiling point for the molecular compound and the melting point also is much more less than the boiling and melting point for the ionic compound. But in this case, for example, when we talk about water, water is a molecular compound. So why it is a liquid? Why it has a relative high boiling point, which is 100 Celsius at 1 atmospheric pressure? The main reason of that is existence of hydrogen bonds. This is why it is considered a very strong type of bonding in such molecules. And if we're going to compare with another compounds, we will see that as we have more hydrogen bonds, the boiling point and melting point for the compound will increases. And as the number of the electrons found in the compound increases, the number of also hydrogen bonds will be increased. So finally, if we have two molecular compounds and both of them contains hydrogen with another electronegative atom, which one do you think that will have higher boiling point? Of course, the molecule that have high molar mass will have higher boiling point and melting point. This is why, for example, when we compare H2O with NH3, now the molar mass for NH3 is 17, because here we have 14 nitrogen with 3 hydrogen, so we'll have 17. While molar mass for water is 18. So because the number of the molar mass for water is higher, and also because oxygen contains two unshared pair of electrons and nitrogen contains only one unshared pair of electrons. So the attraction forces here with the other hydrogen atom will be much more higher than ammonia in H3. This is why the boiling point of water is much more higher than boiling point of ammonia. So the intermolecular force in which a hydrogen atom is bonded to high electronegative atom is attracted where? To unshared pair of electrons of an electronegative atom in an air molecule is known as hydrogen bond. So it makes big difference of the compound to count how many unshared pair of electrons we have. As we said, in nitrogen we have one unshared pair of electrons, while in oxygen we have two unshared pair of electrons. This is why the hydrogen bond here in H2O is much more stronger than the hydrogen bonds in ammonia. As you can see here in this shape, this is H2O. So the hydrogen will attract unshared pair of electrons in oxygen here to form type of network inside the molecule, which will gather the molecules of water together strongly, which will cause raising of boiling point of water. And this is actually why water is liquid at the room temperature. Now our last type of molecules of forces, that we're going to talk about it here is London dispersion forces. And actually, this attraction is resulting from the constant motion of electrons and the creation of instantaneous dipoles inside the molecule. For example, if we talk about helium, which is a noble gas, we know that helium contains two protons with two electrons. This is the helium atom. If we have another helium atom here, same thing, two electrons with two protons. Now in this case, if we have this arrangement of electrons between adjacent helium atoms, we will have a type of attraction between this part between the adjacent atoms. But remember that this is not a permanent situation because the electrons keep moving. So once the electrons move here to this side, then the attraction will be cancelled. So London dispersion forces is a result of movement of electrons. If we have in a second, for example, or for very short time, of the movement of electrons, arrange that the negative side is away from the positive side and the positive will faces the negative side, we will have a type of spontaneous attraction between two atoms. But at the next moment, the electrons keep moving. So at the next moment, the location of the charges will be changed. So the attraction will be cancelled. And actually, London dispersion forces is found in all types of compounds, molecular, ionic, all types. But because it is very weak forces, we don't count it with other compounds when we have stronger attraction. So for example, in water, here, we have London dispersion forces. But existence of the strong hydrogen forces will cancel counting the London dispersion forces. But if we have a compounds that don't contain any type of forces, if we don't have dipole-dipole forces, if we don't have hydrogen forces, then we will say that we have the London dispersion forces inside this compound because it is the only thing that we count here. This is all for our video today. Thank you guys and be safe.